Okay, in part one of this little demo, I've taken the data for the RC time constant for my circuit, and you can actually see that. And let me just pull my Excel over so you can see here's my device. Here's the data that I have. Let's do a tiny bit of analysis before we start messing around with curve fitting. If you take a look at this curve, I'm not so much interested in analog 7, but I am very interested in analog 8, so I'm going to just shut that off for the time being. It's still there, but we don't need it for the time being. Notice that the voltage starts rising in about 6.5 seconds and reaches its peak of 3 volts in 8.7 seconds. You can actually see that in the cursor, right underneath the analog 8, it says time and voltage. So here's what I want to do. I would like to take the data that I have, that's my Excel spreadsheet here, and I'm going to go from about 6.5 to about 8 to about 9 seconds. I'm going to take that data and I'm going to transfer it over to another application that I have, which is Logger Pro. It's a little easier to do data analysis with Logger Pro than it is with Excel, but we can do this in Excel too, but I'm going to make it a little easier for myself. 6.5 to about 8.7. So I'm going to select all these cells from here to here. So I'm going down to about 8.7. Let's just make it around 9 and call it a day. There's 9. Oops, 9 is right there. I'm just going to copy this data, and I'm going to put this into a program called Logger Pro. Now, Logger Pro is a Vernier product, and it's a very good one. I don't down it for a second. Not everybody has it, but as it happens, I do. So what I'm going to do is I'm going to actually paste the data that I have, that I've copied from Excel, into Logger Pro. So let's go ahead and do that. And I'm going to rename my columns just to keep it straight. This is going to be time. This, okay, and then T. Units are seconds. For column Y, this is going to be VR. Voltage in. Call it V in. Volts. Okay. And then this last column, which is the one I'm really interested in, that is going to be voltage across the capacitor. Okay, so we're ready. And what I want, I'm more interested in this curve than this curve. And here you go. Here's my curve. And what I would like to know is, what is the time constant? In other words, how long does it take for the charge to build up from 0, which is down here, all the way up to about 3 volts? And I'm just about there. So I'm going to use a function in Logger Pro called curve fitting. So I'm going to click on curve fit, and I'm not quite sure what this curve would be. You can make, but I'm going to make a guesstimate that it's going to be the inverse exponent curve, which is a1 minus e to the minus ct plus b. And the interest in this is that I want to actually measure the amount of time it takes for the circuit to charge. Well, that you knew that, so let's go ahead and try the fit, and you can see that it fits absolutely perfectly. I'll click OK. I'll make this a little bigger so we can all see it. Okay, here's what's interesting. It's a times 1 minus e to the minus ct plus b. B is about 0.3. It's very, very small, so we'll be okay. Well, what I'm really interested in is C. because that is going to be my time constant. As you can see, the value of letter C is 1.052. Now, how does that actually compare with what we expected from the time constant? Well, let's go ahead and do that real quick. I'll bring up a calculator. And we have a 100 microfarad capacitor tied into a 10K resistor. And so now once my calculator comes up, I am going to go ahead and see if I can't figure out what to expect from that. We say that, in theory, that it should be V naught times 1 minus e to the minus t over RC. So C should be 1 over RC. So let's find out what R times C is. I'll just go ahead and bring up my calculator, starting with the window. And here we go. I want a calculator, so I'll bring that up. And I'll say, okay, what is the value of R times C? R is 10,000. The capacitor is 100, EE minus 6. So that's 100 microfarads times 10,000, 10K. And that should give me 1.0 to a great degree. So 1 over 1 should give you 1, which it actually 1.052. So we're very, very close. We can even calculate a percent difference if we would like. So it's 1 minus 1.052. That gives me that, and I'll take my answer. Divide by what I expect. And I get, multiply this by 100. I get 5.2% difference between what I expected and what I've gotten from the curve fit. In the next video, what I'm going to do is I'm going to take the back end of the voltage when it decays and see if this time constant actually matches.